Hello and welcome. Hi, I'm Ryan. Welcome. Come on in, take a seat. So I'm going to be doing a talk today about Redis, using Redis in dev, test, and production, particularly with the OpenShift service catalog. How many people here are using containers today for any part of their workload, not necessarily Redis? Okay, a couple hands. How many people have Redis in a container? Well, much fewer hands. Okay, yeah, all right. That's where I kind of figured people would be at today. This talk, if you want access to any of these slides, you can get it at this URL here, bit.ly/Redis-dev-test-prod. My name is Ryan Jarvinen, Ryan J. This is my avatar online. If you run into this person online, this is me. And I work at RedHat as a developer advocate. So one of the things I've been focusing on for the last several years, 3, 4, 5 years maybe, has been probably 3 or 4 years. We'll see. We'll get to some commit history pretty soon. But I've been focusing on working with Kubernetes for the last couple years. It's been a big focus for me, so I've been really diving deep into the whole container space. And so I have a couple updates on how things have been going in that world for those of you in the Redis world. So Redis is one of the very first examples to be demoed in coordination with Kubernetes. I would say from the Kubernetes perspective, from the Kubernetes world, Redis examples and demos are a total classic. It's still mentioned very prominently in the Kubernetes tutorials, and if you happen to see the letters K8S together, that's shorthand for Kubernetes. So if you go through the Kubernetes tutorials, you'll see right off the top, their example on deploying a stateless application involves using not only Redis, but replicated Redis with master-slave replication. So it has always been a very prominent part of the kind of user experience and part of what we have demoed in the Kubernetes world. And you could see going all the way back, this is pull request number 7 in the Kubernetes project, was proofreading the guestbook MD, which was talking specifically about adding replicated Redis demos, all the way back at basically pull request number 7 in the Kubernetes history. So it's a long time standard. We like to demo Redis whenever we can. But we've had a particular way of showcasing and delivering Redis in a container. What we've done traditionally, and what you'll see with the Kubernetes guestbook example, is you basically are going to git clone a copy of manifests or spec files, or you'll step into a directory. I'll either git clone or cd, but I'll step into this folder, and I'll pull for any updates, and then I'll use the kubectl command line tool to then provision those manifests or to distribute any updates that have happened in those manifests. So if the ops team says, hey, we need everyone to scale to 4 replicas, they could maybe commit that change into a spec file, ship it out via Git, and all the teams, if they wanted to have a consistent spec'd out configuration of Redis that had the right number of replicas and the right tuned cache and all the right settings, hopefully they can pull down these changes, apply it to their local environment, and be up to date with whatever the team is recommending, right? This works pretty well for small teams for a first stateful example. Although this type of example is going to be destructive when you're rolling out updates. It does a full kind of tear down and recreate, and it doesn't have a lot of granularity between who's the admin, who's the average developer, who's running QA, who's responsible for these different tasks, who's in charge of security, how do we make sure it gets enforced and deployed reliably. There's a lot of things left out in this early example that we'll demo, or that I'll demo through the course of this talk. So I'd like to introduce to you the Open Service Broker. This is, I'll take a quick look at the website for the Open Service Broker. There's actually a Service Broker API that describes how catalogs, in a very abstract sense, how service catalogs and service brokers, brokers are the ones who are kind of offering the catalog content, and catalogs are the one offering it to end users. This is a very kind of a generic brokering and cataloging technology that's being adopted in the Kubernetes world. And you could see Cloud Foundry kind of started off this effort a while back. OpenShift has adopted it, and Kubernetes is adopting this as well. So now we've gone a long way from doing a kind of a git pull and then a kubectl apply to having this nice catalog interface, or at least this is kind of the emerging trend in the Kubernetes world. So this is what I'm going to demo today, ways to deliver Redis using this catalog. All right? So this is really becoming kind of in the cloud native world, I think everybody's service catalog. Like I said, it works with Kubernetes, OpenShift, Cloud Foundry. This one I could kind of skip this point. I just wanted to say there was a recent report from GitHub. They do a yearly analysis called the Octoverse report. And so they did a review of all the most popular projects on GitHub. And last year, the top #1 most discussed out of all repos was Kubernetes. Top repo, more issue comments than any other. So incredibly popular. So you have a huge audience to target using this service catalog, or a huge user base, huge platform, popular platform to hit. The #2 most discussed. Any guesses on this? It was also Kubernetes. The #2 most discussed project was OpenShift, which really kind of is designed to sit on top of Kubernetes and extend the experience with more security features and a multi-tenancy model. So you have more granulation between who is an ops person, who is a developer, and how those security boundaries relate to each other. There's also something that I'll be demoing today. There's a template broker built into OpenShift, and that's the broker solution that will be plugged into today's service catalog. So without further ado, here is delivering Redis in dev, test, and production on the OpenShift service catalog. So this is mostly a couple of demos that I'm going to show to you all. Hopefully this works relatively smoothly. Let's see how it goes. I'm going to start off in a let's see if I could zoom the font here and make this any easier for you to read. This is an OpenShift environment that I created yesterday. I'm going to create a new project. This is one kind of security boundary that we're working with. This is similar in the Kubernetes world to namespaces. How many folks have used Kubernetes before in this room? Only, okay, that looks like maybe 30%, 25, 30%, which is pretty good. More than I usually run into in a room. So I'll make a Redis conf project here. We'll step into this project and I'll browse the catalog. There's a bunch of different items in here. I think over time, I know Google is working on a service broker for Helm charts. So you should be able to use the Helm broker, plug that into your service catalog, and have all the Helm charts as possible catalog options. So if you have a very large company and you're offering services to a lot of different development teams, and you have more than 5 staging areas, having these be reusable components may be a very attractive option. So I'm going to look through here and search the catalog for our Redis option. Since this is my dev demo, I'm going to use Redis ephemeral, since as a developer, I don't care if I lose data, right? So I'm with each of these passes through the service catalog. Hopefully I'm picking the right quality of data store, the right resiliency, the right amount of replication. There's a couple details I could fill in here. I'm going to fill in a Redis connection password of 1234. Since this is just development, I'm going to put in a terrible password. And then we'll hit next. And it gives me an option about binding. This is a major part of the service catalog. You're not just provisioning a service, but you're actually getting credentials and binding it into a running service. So I can either create a secret in this Redis conf project that can be used by applications. Then they'll be able to auto-configure for this particular set of credentials, that password I typed in, 1234. Some front-end web app is going to need to know that password. And this set of credentials and this binding is going to be how that password gets relayed. You could also say, do not bind at this time, and create bindings later. I'm going to create a secret that we could bind to. And it looks like Redis is being provisioned. Now if I go back to this overview, I can see that I have a provisioned service that's being fulfilled and a deployment of my Redis container that's coming online. I can also do, to make this demo a little bit more, only slightly more full-featured, I'm going to browse the catalog again and add a front-end environment to work with. And I'll call this output, because that's really what I'm looking for, is environment output. Let's call this config. I'll just call it out. I'm going to call it out, standard out. And the Git repository for today is github.com, Ryan J, Redis Conf 2018. So this is a much more kind of Heroku-like experience than the folks who have used Kubernetes before probably haven't seen it look nearly this slick. So what I've done now is I've provisioned a Kubernetes deployment with the Redis image, and I have another deployment that is on the way based on that Git repo. And you could see here I'm running a build. I'll actually tail this build. We could follow these logs and watch the build happen right in our dashboard in OpenShift. You can add additional test cases into this build process so you could have some feedback for the developers. It looks like the web application has finished being built into a Docker image. That image is getting pushed into an internal registry within OpenShift. And then when that Docker push is completed, we'll automatically do a new deployment that'll ship our container. So that's what we should see spinning up right over here. Once that's done, I'm going to do it while we wait. I'm going to go to Services. And I'm going to create a route. Uh-oh. Route out. Oh, I guess we already have that route. Okay, here is our route. Looks like the app's online. And really all it does is dump our environment configuration. So we could already see that there's a Redis port configuration in here. Here's the Redis service port. Here's the TCP address where we could find Redis. A couple other goofy configs in here. Some of them, here's a TCP port, full address. Variety of different ways that these credentials are exposed in here. A lot of this is specific to JavaScript, the JavaScript environment and the Node.js runtime. We could also go right into a terminal in here and take a look around. You could see that PID1 is npm, so we're clearly inside a terminal, inside a container, full access to our dev environment. So this is pretty nice. I could go in here, make a change to our index, and say instead of welcome to RedisConf, we can jump a year into the future and say welcome to RedisConf 2019. I'll reload this page right there. RedisConf 2019. All right, so we could do real-time development with a fully container-based tool chain and take advantage of Redis for part of that process. So that's my first demo, iterative development with Redis ephemeral. Any questions about that? Does that make sense? Has anyone seen containers be that easy to mold, easy to work with on Kubernetes before? I doubt it. It's pretty good. So we've all, question?
So in that world where you made the change, and you sort of saved that change somewhere, would that be like a git push or something?
Exactly, yeah. I made that change right in the container. Containers are generally stateless and immutable. What I could also do is make that change right on GitHub, set up a webhook so that GitHub notifies my OpenShift environment, and then as soon as I make the change, as soon as that commit push lands in my registry, we'll automatically fire a hook, rerun the web build, re-push that image, and do a new deployment. So that would be this next demo, which we don't really have time for, the full route with a git commit, but you've already seen the kind of basic proof of concept, and the result would be more or less another deploy would kick out. So we'd have something that would look a lot like, boom, I'll hit the deploy button, and we could see a rolling update going across these. So that's our basic dev. We can get feedback from local iteration on these containers pre-commit if needed. For testing, of course, you want to select the right services and data sets that meet your specific performance criteria and your specific needs. So if you want to test production quality data, that might mean a couple different things to you. It might mean that you have replication working and you want to be able to test automatic failover. You might want to actually have a real snapshot of some production data if your privacy policy allows. You may want to have actual production data that you're testing against in some cases. So there's a lot of different ways that you can assemble these environments. That last one, I went in and picked the pieces individually, kind of a la carte out of this service catalog, but we can also package them up together as a prepackaged option, and we'll see that in the final demo. I'll go through one more time. I'll pick let's see what I have in this other project. I'll go through this project again and do another search for Redis. If I pick the non-ephemeral version of Redis, I'll get a slightly different, I'm going to leave the password blank as well. We'll see what happens when I leave the password blank. We'll create a secret and go through to the overview page. So what's different with this version is this non-ephemeral Redis is using some of our storage. So we've created a persistence volume for Redis. Then if the Redis container is deleted, rebooted, restarted, any of these things, will automatically get the exact same volume mount reattached to the container, hopefully give us a stateful, real stateful application, right? You can play with real stateful stuff before you get to your test phase, but that's the usually the first part where I start caring about statefulness is once I do testing. Yeah.
So then that means that when it's writing the backup, whether it's the RDB file or it's the PNG file, it would be writing that volume?
Yeah. Any kind of state from that, backups would be going to this volume. There's also other more, this doesn't handle automatic snapshotting yet. There are more features like that could be handled by your service catalog, but it's not currently covered, at least with what OpenShift offers. Redis Enterprise or Redis Cloud may have backups or snapshots available. So I am going to do a quick demo of, since we're talking about failover and recovery, I'm going to show really quickly in our other project what it would look like if I scale this up to 5 containers. I log in and get our list of pods. I'm using on the command line here this OC command line tool, which is usually used with OpenShift. You can also use, and I'm going to do project Redis conf. Okay. And you could also use kubectl get pods as well. Since OpenShift is a Kubernetes environment, this will give us pretty much the same output as our OC get pods. The only difference is, no, they both show the build. Yeah, I can't see any difference here. Yeah, OC get pods, kubectl get pods. OC just has awareness of other non-native abstractions that are only available in OpenShift and not available in Kubernetes, but you can use the OC command line to do anything you can do with a Kubernetes command line tool. So I can do kubectl delete pod and delete, let's see, I'll delete this one, and how about this one here, and we'll get one more, and we should see in the dashboard a change right away. Looks like our app is responding. Okay, I'm going to delete these. We should see immediately our dashboard recognizes we're fully responsive the whole time, and it's auto-scaling us back up. It has enough redundancy where I could keep deleting more and more containers, and it's just going to keep adding up to our requested level of 5 pods or 5 containers. So that kind of auto-recovery is something you can expect from Kubernetes. I just demoed it with the web front end. I would like to attempt to demo it with our Redis backend as well, and that would be my next production demo. So for production, this is what you really want out of your Redis is to be able to have failover replication if you're going to use Redis with this service catalog, right? So hopefully let me put as many of the pieces together as I can with the current state of the service catalog. It's still an early project, but hopefully this gets you excited about using it down the road. So here's my warning for this demo. Do not use what I'm about to do in production. This is the latest that I could piece together of what's available today. I'm not the most state-of-the-art on clustering Redis. There are people who are much more advanced, and I borrowed some of their notes. and their notes are maybe a week or two out of date. So some of these problems, I'm sure in the next 2 weeks, we'll have much bigger announcements about Redis in the service catalog, about clustering Redis, and about using Redis with stateful sets. I know there's a lot of news on the way at KubeCon EU coming up in the next 2 weeks. So keep your eyes peeled and your ears open. Here's my quick demo. So I will do OC create -f, and I have a Redis cluster template. So what this OC create command just did is it installed the template into the template broker, which is being monitored by the service catalog. So now if I go back to the service catalog, I am gonna pick a new project just to be totally safe. Cluster demo. Let's try this out. Go into our cluster demo project. Oh, I need a OC project, cluster demo. Make sure I install that into our cluster demo project. Like I said, these projects are kind of like security boundaries, and you got to install it into the right security boundary. So now I ought to be able to search the catalog for Redis. I'm gonna hit browse, go to other, and now I have a new item, Redis cluster, that was not there earlier, right? This is a custom item that I just added. I could have added a front-end environment with a repo URL as well. I could package up, the full thing to hand off to my web team, whatever quality environment I want. They need a clustered environment, I could give that to them. If they need a ephemeral environment, they need an environment with another environment stapled to the side. You can package all these things together and install them as new items in the service catalog, make them very easy to launch a la carte. So here I'll go into this Redis cluster, and I'll launch this. This one takes a little while to load because it's doing it's doing a real cluster with 3 masters and 3 replicants. And it's also using persistence volumes for all 6 of those. And it's using a stateful set in Kubernetes as well. So if I go to stateful sets, I could see our Redis cluster. I could see it's currently at our now at our second. It's building out the stateful set one at a time. And if I do kubectl get pods, should be able to see that each of these are coming online. Redis cluster 0, Redis cluster 1, and that'll go out and it'll continue working, building out each of those 6 instances in our cluster. I think according to the Redis cluster spec, these are supposed to have like 6 gigs of RAM per instance. So I'm not surprised that not many people are doing this in containers today. You need a particular kind of scale to need to do these in containers. But this is, I think, the future of how we'll see these environments come online. I'll do one more step to join the cluster. We'll try to delete a couple masters and see if it will auto heal on the DB side as well. Let's see. Any questions while I'm waiting for this? I'm going to show, if I don't have any questions, I'm going to jump back into our other project, go into the terminal, and run Redis CLI cluster nodes. Oops. Authentication required. It's because I left the password empty, I think. Well, I got another Redis over here. Let's go for this one. pod terminal. So Redis, CLI, cluster nodes. We could see, oh, yesterday I was getting a, here, this is what I was looking for. No, not what I was looking for. I was hoping for, this thing is not configured for cluster usage because it's a single instance. That's the response I was looking for. I don't know what I typed in yesterday, but that was on one of the single instance ones. Let me go to our multi-instance. This one, I'll pick a random number of these, and I should be able to run Redis CLI, cluster nodes. So right now I've just had a single, right? They're not joined. I need to join these. And I have a command right here that ought to get the job done. This is going to run an exec into Redis cluster 0. On that node, it's going to run Redis Drib, create one replica per leader on this particular list, and it'll just grab IPs from the kubectl command line. And here's the result. Do we accept this configuration? I'm going to say yes. We'll join the cluster. Now I should be able to run this same command again. Cluster nodes. Oops. Watch Redis CLI. Okay. Is that readable by anyone? Can we see that we have, basically we have in the terminal, we have a status dashboard showing the status of our Redis cluster. It looks like we have 6 nodes all joined together. The one that we're currently logged into is a slave. And we have a couple masters. We can see their IP addresses here. In the console here, I'm going to do delete pod. And I'm going to take out the first 2, Redis cluster 0 and Redis cluster 1. And we could watch on the dashboard and see what happens. Looks like one of these masters was marked with, let's see, we're only getting updates every 2 seconds. So these 2 just fell offline. This one here and this one here fell offline. This one's getting marked with fail question mark. This slave just got flipped to a master. So we just had a backup take over. New master came online over here. So we're back up to 3 masters and 3 slaves. According to this output anyway. So I don't have a sophisticated enough front-end app to tell us whether this is fully functioning and whether that would have survived a outage to, like if I was doing a pub sub on the front end, that was what I was hoping to demo, was do a front end pub sub and then kill half the Redis nodes and then watch that we had no interruption on our pub sub stream, right? Even with this massive outage. So this type of auto recovery is not for production today, unfortunately. I know with Redis 4, there's some new features that make stateful sets much more practical, much more usable, and much more failure-proof. One of the problems with this is when the auto recovery happens, you can sometimes end up on a different IP address, and that causes some major problems for Redis. So I think with the 4.0 version, there's support for doing something slightly different. I don't know if you bind to a host name instead of an IP address, or maybe you stick with IP addresses, but you have a stateful set per IP address instead of one stateful set for the whole thing. The implementation probably won't matter as much particularly for you folks because you'll be able to grab the latest reference implementation from Helm charts, from other service catalogs, from Bitnami, from a lot of different outlets, from OpenShift templates. There's going to be a lot of people that'll be refining how do we package up a clustered Redis with your input, hopefully. So let me get to those slides. A more practical way to link to a large-scale Redis would be use something like Headless Services, in which case you'd be creating a Kubernetes service that works with Kubernetes Service Discovery, but it points to a service that actually lives outside the cluster. So for any legacy services, cloud-hosted services, something like Redis Cloud that's already resilient and scalable, you could use something like a headless service to let Kubernetes and the Kubernetes Service Discovery announce the presence of this type of thing. So this is another thing where you could make it not just in the service catalog, but other services need to be aware of this service at runtime, and that's where this headless service feature comes in. Telepresence is another thing you could look into if you're trying to make production scale things available for development use cases. This works pretty nicely with Minikube or Minishift for getting your access to your large Redis cluster available to developers who are using small dev-sized environments. Other ways to extend this, I think the Kubernetes world is really into the idea of extensibility and making everything cloud native and portable and easy, modular, easy to reconfigure. So I think you want to pick the right tools for your solution. You could use the Kubernetes service catalog and definitely take a look at the Kubernetes has a special interest group that meets around this service catalog topic. There's also a special interest group around stateful sets, so that's another one if you're looking to get involved and to learn. Both of those special interest groups are have really great content for I think Redis audiences. And there's a lot of other things you can plug in. Like I said, these brokers, there's something called the automation broker that was made by the Ansible team. They made it so generic. The upstream of this is just called automation broker, and it doesn't have anything to do with any dependencies on Ansible at all. It's meant to do generic automation. You could have it integrate with other things other than Ansible, but there's a specific instance of this that uses Ansible to do automation that you could also look up if Ansible meets your needs. There's a DIY broker example around MariaDB that I was hoping to rewrite into a Redis broker. No one's done that yet, so if anyone's interested in writing their own broker for Redis, I don't know how practical it is, but it would be a nice demo. We use the OpenShift template broker today. There's a Helm chart broker from Google that I've linked to. Feel free to check that out on GitHub. Cloud Foundry has a Spring Cloud broker and a couple other brokers available. Other ways to extend Kubernetes other than brokers, you could look into things like custom controllers, custom resource definitions, or there's something from CoreOS called operators that's basically a combination of these two standard terms. Anyway, let me know if you have any questions about this. I'd be happy to answer any follow-ups for you all. My big 3 takeaways from this talk are using the Open Service Broker and Service Catalog provide a great way to deliver containerized Redis as a service on a variety of popular cloud-native platforms. You can use the Service Catalog with the template broker to offer targeted use cases that are specific to development and test and security that you might not get with just Kubernetes alone. And of course, you can expand your catalog offering by building your own brokers if there isn't a broker that already meets your needs and already a catalog offering that fits your bill of criteria. So here's one of my last slides, resources. Definitely check out the Kubernetes Service Catalog SIG and Stateful Set SIG if you want to find a community of folks that are refining those particular topics. I've got one last link to the Open Service Broker API website, Automation Broker, build your own broker example. And of course, we've been looking at OpenShift today. You could get free accounts on OpenShift.com. It's available as an enterprise product offering as well. And of course, if you want to learn anything, check out learn.openshift.com. We have some kind of self-guided learning experiences. I'm planning on trying to add some Redis examples in there soon. That's all for me. Thank you all for staying around. Let me know if you have any questions. Thanks.